Okay, so the next unit we're going to be going through is covalent. For covalent bonding, this is going to be different from your ionic bonding because it's a sharing of electrons, where ionic bonding was a transferring of electrons. It's also different because if you remember, ionic bonds could conduct electricity when in solution. Covalent can't. Also, ionic bonds was a metal plus a nonmetal, where here covalent's just nonmetals. So the first thing that we're going to go through is our naming. So for the naming, since we don't have those transfer electrons and we don't have those charges where we could swap and figure out how many we have, we do need to use prefixes to indicate how many elements we have. So the only one that we don't use a prefix for is the first element. If it has 1, we don't put mono in front of it. So here we have just sulfur. We have 2 oxygens, so we'll use the di, and then you always change the ending of your second element to oxide, or to ide. So it'll be dioxide. Next one, again, we don't use mono in front of carbon because it's the first element. We do use mono in front of the second element, so that's why we have carbon monoxide. If you notice, I didn't do double O's there, even though the prefix ended with an O and the element started with an O. You're not going to use the double vowels, you're going to lose the vowel from the prefix. Next, we have nitrogen, but we have 2 of them, so we do need a prefix in front of the first element, so it's going to be dinitrogen. And then we have 4 phosphorus, so that'll be tetraphosphide. So I would suggest for your note card, go back through covalent, write down all the prefixes on your note card. So this wasn't the biggest part of the unit. We actually only probably spent, I think, a half day on that naming. So the biggest part was our Lewis structures. So for Lewis, we had 5 rules. So the first thing we had to do was we had to do our math. Second thing you had to do was you had to draw a skeleton structure, then add 6 dots to everything other than your central atom. Keep in mind, hydrogen is an exception to that rule, and hydrogen's happy with just a line, so you don't add dots to hydrogen. Step number 4, you then count how many electrons you put on. If there's any extra electrons, you are then going to put those on your central atom. And then step 5, if your central atom doesn't have 8 electrons, you're going to make a double bond. So there's a mistake right here. So I forgot to put the charge of our SO3. So this has a 2- charge. So go ahead and add that there. So we're going to have to do our math here. So sulfur, where it has 6 valence electrons. Oxygen also has 6, but we have 3 of them, so I'm just times that by 3. And then if you remember, if it's a -2, that means we have 2 extra electrons, because electrons are negative charge, so I'm going to do +2. So I end up with 26 here. So that was step 1. Step 2, you're going to always draw your first element as your central atom, unless I tell you otherwise. So I'm going to draw sulfur in the middle, and I'm going to draw 3 oxygens around it. Step 3 is we're going to add 6 dots to everything other than your central atom. Remember again, we don't have hydrogens here, but you never add those dots to hydrogen. Okay, so step 4, we have to count how many electrons I've used. Keep in mind that the line, our bond, also counts as 2 electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So here I have 24 electrons that I've used. I have 26 that I could use. So for this, since I have an extra 2 electrons, I'm going to put those extra 2 electrons on my central atom. And then I'm going to move on to step 5. So if the central atom has 8, we are going to be done. So looking at our central atom, it has 2, 4, 6, 8. So we are done here. If we didn't have these up top, then our central atom would have only had 2, 4, 6. So at that point, you would erase 2 and make a double bond there. So we don't have to do that in this case because our central atom already has 8. Let's go on to the next example. So Se has 6 valence electrons. Hydrogen has 1, but we have 2 of them. So I get a total of 8 valence electrons. So that was step 1. I'm going to put Se in the middle. I'm going to draw 2 H's around it. So that's step 2. Step 3, you add dots to everything other than your central atom. Remember, you never add dots to H, so I'm going to leave it just like this. So I'm going to go on to step 4. I have to count how many electrons I've used. So I've used 2, 4. So that means I still have 4 left over. So I'm going to put those extra 4 on our central atom. And then our next step, step 5, I have to see, did I use 8? So does my central atom have 8? So I have 2, 4, 6, 8. So I'm done with that one. So moving on, the next thing that we did is we used our Lewis structures to figure out what the actual geometry looks like in 3D, so non-paper version. So here we had to look at how many bonding domains and how many non-bonding domains we have. So remember, your bonding domains are how many elements are off your central atom. Remember, a single, double, or a triple bond all counts as one bonding domain. So here I have 3 bonding domains. Over here I have 2 bonding domains. Your non-bonding domains, those are your dots on your central atom. So how many dots did we place in the central atom? And for this, we're looking at pairs. So here I have 1 pair of dots, so I have 1 non-bonding domain. Over here I have 2 pairs of dots, so I have 2 non-bonding domains. So to figure out our actual geometry, we're going to look at that sheet that we used in class, and we're going to look at which one has 3 and 1. So we're going to pull out this sheet right here. I'm going to look at which one is 3 and 1. When I do that, I see it's right down towards the bottom. It's this trigonal pyramidal. So that would be my shape that I would write down here. So this will be pyramidal. Next one is 2 and 2. So for 2 and 2, I have this bottom one right there of bent nonlinear. So this has a bent shape. And then once we figured out our actual shape, we moved on to polarity. So for polarity, we had some rules of how to figure out if it's polar. So it's polar if any of these cases are met. So if there are different elements off the central atom, if there are dots on the central atom. So this rule works for all the shapes that we do in this class. It doesn't work for all shapes. So there are exceptions if you go on to a different chemistry class, but it works for us. Or if the molecule is not symmetrical. So when you look at symmetry, you have to actually look at the molecular geometries. So the reason why, if we look up at this shape, this looks symmetrical. I could cut it this way, the top and the bottom look the same. I could cut it this way, the sides look the same. But what it actually looks like in real life is this bent shape right here, which if I cut it this way, the top and the bottom don't look the same. So you have to look at the actual geometry shapes to figure out for that one. So the first one we look here, so I notice right away there's dots on the central atom. So that's going to make this one polar. Same thing for the next one. Next one also has dots on the central atom. So this is also polar. So you're going to use, to give you an example of a nonpolar, let's say we had like C, H, 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 H. So here, everything coming off of your central atom is the same. There are no dots on the central atom, and it's symmetrical. So this would be an example of a nonpolar molecule. Now, if I changed one of these to a different element, let's say like a fluorine. So if I look now, there are different elements coming off your central atom. So this now, I just made it a polar molecule. So that's how we can kind of use the rules to figure out if it's polar or nonpolar. And remember, polarity means if there is an unequal sharing of electrons. So if it's polar, that means that one of the elements wants those electrons more, or has the higher electronegativity. So it's pulling on those electrons more than the other ones. So go ahead and start working on your note card for covalent.